Hi there! Today I'll look at remote control USB powered LED string. So I know that Christmas is over already, but what I wanted to show you here, this is very interesting because it's fairly cheap, free, $4 or something like that, and it has a actual remote with a battery inside, so it comes with a battery actually, which is interesting because depending on where you look, those batteries can cost, I don't know, half a dollar, 25 cents. This is CR2032, which is nice. It doesn't say what kind of brand it is. I think it did say here, but they are scrubbing this off for some reason. I guess maybe they are producing this in another factory. So let me quickly show you how this works by connecting this power bank. And you can control this using a button only. It has only one button, this blue one. So this is a multicolor one. There are also available, from what I saw, cold and warm white ones, and I think other multicolor ones. I'm not sure about that. But one thing you should also notice that they are very specific, a little bit weird. I'm not sure how to phrase this. Cold color LEDs. They are not exactly vibrant colors, so they're a little bit different if you look at them, in a normal light, because the camera may not do it justice. Those colors are not exactly popping. So if you are looking for those, it's not exactly this, but at the same time, I would like to show you how this is all connected so you can replace those LED strings. So it has only one button, like I said, and you can every time you press it, you will change its mode. So yeah, it has also a blinking mode. From what I noticed, it has two channels for those LEDs, because it can also operate them. Yeah, strobe effect. It can operate them without powering the other channel. Let me just quickly take a look. The red one and the white one are powered together, and the green and blue one are also on another channel. So this is what you get. To turn it off using the button, just simply press and hold it. So once you turn this on, there's this remote. So it has, you can switch all those modes with a number here, but also it's available for you. You can change the brightness of those LEDs. I'm sure if that's very visible, but there are 8 levels of the brightness, and the really dim one is really nice, actually, to be honest. But you cannot fix this using this. If you turn it off, it will remember the brightness, if I'm not mistaken, and turn it on again. So if I disconnect and connect it again, will it? Yeah, so it will reset after disconnecting. So it defaults to the maximum brightness. Yeah, so it has 8 levels, on and off buttons, and also what remote can do is a timer. So if you press it once after you turn this on, it will blink, so it enables a timer. So for now, according to the instructions, for next 6 hours it will be lit, and then will go off for next 18 hours, and then again go turn on again for next 6, and so on and so forth. So you presumably would do this at dusk, turn it on, press the timer once, and then let it run daily for 6 hours when you're up and about your room, and it will lit by itself. If you press it one more time, it blinked twice, and presumably this is disabling this function, because if I press it once again, it blinks once, and then it blinks twice. So this is what you have from the remote, and those are all the functionalities. Now we can take a look a little bit inside of this. So firstly, what I can tell you about those remotes, the type of the remote is actually very similar to if you have a transmitter for your car. It has almost exactly the same remote with this metallized plate here. And also those remotes, where they don't say in the instructions, they have a film protection protector. So let me just try and remove this. So, well, you may not want to remove this because otherwise it will be prone to scratches. I don't really care. So it looks like exactly this. And now how you disassemble those is just by removing the faceplate over here. Let me just find a place, or just let me try to bend it a little bit. Here we go. Let me remove this. Let's try to work around this, and here we go. So this is all you have. On the other side there are only buttons, and that's basically all. These pins are pressing here on the minus, and this is a plus, so this is a plus here. And that's all. That's everything you have here. And also small infrared LEDs. Not sure if the camera will catch its light. Let me try this actually. Does this work on this camera? Not really. So either this infrared is very dim. No, it does. So that's basically all. So that's the remote, and let's take a look inside this. I will open it in exactly the same manner because I don't see any screws here. Also, we can quickly take a look at the connections because this is the end of the circuit. It would seem that let's start the blinking here. It has a reverse polarization for those LEDs. So because it only connects to cables here. If I'm not mistaken, that's right. So that string would be constantly turned on if you connect an AC power to this, because let's say that this is connected, you have left right, and this has connected left plus and right to minus, and this is the other way around. So that's how they achieved 2 channels with only 2 cables. That's probably the way they did it. And if they are running, that's really interesting. If they are running constantly on, they are probably just blinking very quickly. I'm curious what's the frequency here. If I remove a little bit of insulation here, or maybe I will just probe the board. So we will check the frequency, how this is what this is working at, because it powers all of the LEDs at the same time. When you take a look with your bare eye, but actually I think it will try and provide AC to those LEDs. This is actually very nicely made. I'm really impressed with that. It's quite pleasant, and also it's already USB powered, so you can connect it basically everywhere. Okay, and here we have it. Oh, it's glued on, so that's extra nice. This is infrared receiver. This is our main chip. Oh, is it glued on? So that's the main microcontroller, presumably. Yeah, because on this side there is only a crystal that provides the the frequency, probably for the it's either for those LEDs, but I think it could be frequency to time for this chip to have a time. For those 618 hours mode. I will look closer at this chip, but firstly let's check that frequency, because I'm quite curious. I think that's in kilohertz. Yeah, that's interesting. Yeah, 7.7 kilohertz. So if I connect a speaker to this should be audible. Give me a second. Okay, so here's our speaker. I will just connect it to the output of the those LEDs basically, so you can see also how they function. And if I change the modes, yeah, keeping it dim helps with the. Well, that's not exactly recommended because it's heating up this little chip, but putting that aside, let me bring up the brightness here. putting that aside, this is very interesting. So it only uses 2 wires, and let me draw you how this does this exactly work. To put this really simple, it's, well, let's call this a power source. It's not exactly, but let's call this, or maybe on oscillator, right? So AC power source in general manner, and you have those LEDs. I will just draw 2 because you can just simply group them. So you have all of them connected to this AC power, and that's all. So this is our signal generator over here, and those are the groups of LEDs. So this is, let's say, white and was it red, and this is blue and green. And that's all. That's basically the whole circuit here. So on the output, what it is doing to make sure that your eye can perceive that it's constantly on. So let's show you something like this. So it's basically doing a standard sinusoid, because, and that's at 7.7 kilohertz. So all your eye can see is basically them on all the time. And now, if you consider that it turns on once one LEDs and then turns off the other every, let's say, half a second because it's blinking, so it's doing almost this, but in this manner. So the way the AC would look like, so it does something like that. Let's ignore this because it also let's say introduce the brightness, so you can dim it and all the things, all the things. It also can have some kind of breaks in case it needs to be a little bit dimmer, and if it runs at 7.7, it also, let's say for this one, it will only light the white and red LEDs. So what your eye would perceive is that white and red LED is lit, and the blue and green isn't, because it only is doing a half wave. So because the current is flowing through the white and red, in this instance it's basically omitting this these LEDs, because it doesn't run over its reverse voltage. So because that would broke in any of the half wave, one of those sets. So basically this is safe, and also doing this like so, and even doing some of the breaks, or changing the whole sinusoid to, for example, instead of doing something like well, for example, this standard sinusoid, it could start doing something like this, or completely doing a small points, and it will, your eyes at that frequency would still perceive those LEDs to be lit constantly, but on a reduced brightness. So that's exactly how they achieve this on the 2 cables, which is great actually. So they are doing absolutely everything with this little crystal and this chip. These are the numbers that are on the chip, and I only found this single information that I think it's I think it's made by Triton Technology Inc. Here it is, and it seems that it has a program memory of 2K times 12. Not sure if there are 12 banks or how that would work. It also has 128 bytes times 4 of RAM, which would be enough in this instance. There are 6 I/O ports. There is no comparator or op-amp. There is no analog to digital converter, which, well, that doesn't change anything here. User information block, not sure how that would work. Oh, that's interesting. Reusable code. I'm not sure exactly if that's applicable here, because that would mean that UV can erase it somehow. 1 to 16 megahertz. No, that's not a feature. And the package is SOP 8, so 8 pins just like here. So that would be okay. It also has a reset flag, which is interesting because it has already 6 I/O ports. So I'm not sure how that would work, because there has to be ground, power, and those 6 I/O ports. So that's all 8 pins. You have to log in to download the datasheet, so I won't do that. But that's basically all I found on this chip. Okay, so here's one last thing I wanted to measure. I connected in the parallel this meter, so I wanted to check the milliamp. How much milliamp does it take? Let's call it 125 and that's at full power. And if I change those modes, it start to it should decrease a little bit. And this mode runs half of the LEDs at one time, and it will shoot those colors and so on. So it runs on half of the power, and it's actually even less, because 60, up to 60. So this is constantly blinking, and because it's you can say the power draw is actually AC. I will be able to measure this. I can a little bit, because it changes very frequently. And let's see, these are the other modes. This is the fairly quick blink. So maybe in the AC mode I will have something. Yeah, as you can see, up to 60. So it runs only half at one time, and that changes quickly and so on. So at full brightness, this whole circuit takes 120 amps. If I decrease the brightness, it goes down. The power draw is milliamps. The power draw at decreased brightness is only 23 milli, so that's a very small percentage. And especially if you are in the mode where only half of those LEDs are turned on at the same time, it goes like this. So this is quite interesting. So the power draw is quite okay, even if you use this on a power bank, like this one over here, which has only a little bit over 1 amp hour, which isn't a lot. But if I turn this off, the power draw drops to something like 23. But that's quite interesting, because if I press the button every time I do that, even though it's an off button, but it still receives a signal, it increases the power. It's taken to 3 milliamps. So presumably every time someone will press a button on a remote somewhere in the vicinity to turn on the TV and so on, and if I try and if I turn it on again, that's again the same. If I disable this completely and just connect it, it takes 3 milliamps for a moment, and then drops to the 0.2, which every now and then it increases. So presumably over time it will take about 1 milliamp, and that's not a significant power draw, so that should be still fairly okay. So as you can see, it's over 1 milliamp every now and then. So that's basically it. Thank you so much for watching. I hope you enjoyed and you learned something about how these are made. That's really nice, if I say so myself. And see you guys next time.